An interstellar visitor has entered our skies. But it may not be travelling alone, and the swarm that follows could change everything we think we know about the universe. Ever since 3I Atlas was first spotted in July, things have grown progressively stranger up there. Its green glow and alien chemistry would be astonishing enough. But what has captured astronomers is the unsettling possibility that Atlas is not travelling alone. In its wake, the skies have grown crowded. One comet after another has appeared. Why now? Why so many? Is there a deeper pattern we have yet to see? Is Atlas a single shard flung from a distant planetary system? Or part of something larger, a chorus of visitors whispering to us across the void? These are the questions we'll gently explore tonight. Science can explain much, but it also leaves space for wonder, and in that wonder, imagination takes root. Stay with me as we uncover why October 2025 may unravel everything we thought we understood about the cosmos. Let's begin. In the months after Atlas was discovered, the skies grew crowded. One object after another appeared, asteroids, comets, and fragments, as if summoned into the same celestial stage. The timing was too convenient, raising questions about coincidence versus coordination. Astronomy, for most of its history, has thrived on predictability. The motions of planets can be mapped centuries in advance. Comets, once their orbits are measured, return at reliable intervals. Asteroids, though more numerous, still fall into familiar patterns that can be catalogued and tracked. But in late 2025, the heavens seem to rebel against that sense of order. One discovery followed another in quick succession, as if the sky had suddenly decided to put on a performance. It began with a wave of near-Earth asteroids, some passing close enough to capture headlines. Then came the comets, Swan, Pan-STARRS, Lemon, Neat, and others, each making their approach within months, or even days, of one another. And threading through it all was Atlas itself, the emerald wanderer from another star system. Observers couldn't help but notice the clustering. It was as if the universe had chosen a particular season to unveil its secrets. From the ground, it looked like a cosmic traffic jam. Telescopes turned frantically, their schedules overwhelmed by targets that normally would have been spread across years of quiet observation. Amateur astronomers, too, found themselves spoiled for choice. Capturing images of comet tails overlapping in the night sky, or plotting asteroid flybys that skimmed Earth's neighbourhood with unnerving precision. For scientists, the question quickly became one of probability. How likely is it really for so many objects to converge in such a short span of time? The answer, by their calculations, was not very. Statistically, the clustering should be rare, the kind of coincidence that might happen once in many lifetimes. And yet, here it was, unfolding before their eyes. Some pointed to the improved power of our surveys. The Vera Rubin Observatory, with its vast digital field of view, had only just begun operations. Perhaps we were seeing more simply because we were looking better. But even with that explanation, the sheer concentration of arrivals felt unusual. It wasn't just that we were discovering them. It was that they were arriving all at once, their paths intersecting the inner solar system like streams feeding into a single river. And then came the speculation. Could gravity have nudged them? Was there some alignment, some subtle resonance in the solar system that had drawn them inward together? Or was there something stranger at work, a force we don't yet understand, coordinating their timing in ways we struggle to explain? In the calm of midnight, such thoughts linger. Were these objects merely travellers sharing the same road by coincidence? Or were they companions? Parts of a larger pattern, drifting toward the sun in synchrony. For a discipline built on precision, these questions can be unsettling. Yet they are also thrilling, because they remind us that discovery often begins when the expected gives way to the unknown. That autumn, as astronomers lifted their eyes to a sky suddenly full of strangers, one thing was certain. the solar system was no longer quiet. It had become a stage, and the actors had arrived, all at once, as if summoned to the same scene. As Atlas approaches its closest point, it may brush by Mars at a distance small enough for our robotic probes to study. Cameras on orbiters could turn their gaze outward, giving humanity what might become its first interplanetary vantage point of an interstellar wanderer. Until now, every interstellar object has been studied only from Earth. Our telescopes, powerful though they are, must fight against the atmosphere's haze, weather, and the sheer limitations of distance. But in early October 2025, Mars offers us something new. Its orbit carries it into near alignment with Atlas's path, placing our robotic scouts, machines built by human hands, in the perfect position to observe the green traveler up close. Consider what this means. For the first time in history, we aren't bound to a single viewpoint. From the surface of Earth, Atlas appears as a faint smudge against the stars, its colour more suggestion than certainty. From Mars, however, the story changes. Instruments orbiting the red planet could capture light, unfiltered by atmosphere, measure spectra with greater clarity, and record the wanderer against the black backdrop of space. It is like suddenly opening a second pair of eyes. MAVEN, the Mars atmosphere, and Volatile Evolutio N orbiter may repurpose its sensors to glimpse the interstellar visitor. The Mars Reconnaissance Orbiter, with its high-resolution camera, can turn briefly from canyons and dust storms to capture frames of a cosmic stranger. Even Perseverance, roving across the dusty Jezero crater, could aim its cameras upward, catching faint traces of Atlas as it swept past in the Martian sky. And this is more than science. It is symbolism. Humanity, still confined to one planet in body, could extend its senses outward, turning a neighbouring world into an outpost of discovery. Our presence on Mars is no longer only about rocks, soil, or ancient rivers. It has become part of a grander watchtower, helping us monitor the flow of the cosmos itself. But there is also wonder in knowing that a world we dream of stepping on one day could witness something we can barely see from Earth. Mars has been given a front-row ticket to the performance, and through its machines, it can share the show with us. In the coming days and weeks as Atlas sweeps past, heading closer toward the Sun, it will carry with it the silent knowledge that it is being watched from two planets at once. For humanity, this could mark a quiet milestone, our first interplanetary collaboration in studying a visitor from the stars. Spectroscopy revealed Atlas's shimmering green colour was caused by molecules fluorescing in sunlight. But the exact balance, diatomic carbon, cyanogen, perhaps something else didn't align with expectations. It was familiar, yet foreign. For centuries, comets have been described in colours: bluish-white tails, faint golden dust streams, the pale grey glow of icy cores. But Atlas was different. Its green tint was no optical illusion, no trick of human eyes under dark skies. It was written into the very chemistry of the comet's coma, the cloud of gas and dust that surrounds it as sunlight stirs its frozen surface back into life. In most comets, diatomic carbon, two carbon atoms bonded together, is the primary culprit for flashes of green. When exposed to ultraviolet radiation, this simple molecule fluoresces, glowing with an unmistakable hue. Cyanogen, a compound of carbon and nitrogen, can also add to the effect. Together, these molecules can give a comet a ghostly emerald halo. But in Atlas, the glow was unusually strong. The balance of emissions didn't quite match the patterns we've catalogued from comets born in our solar system. Something about Atlas's chemistry seemed out of place, as though it spoke a dialect of molecular language we had only half learned. This wasn't just a curiosity for scientists. Colour is data. It tells us about composition, about the ices locked in a comet's interior, about the environment where it first formed. The strong green signal suggested Atlas carried volatile compounds in greater abundance than expected, perhaps shaped by conditions in a planetary nursery. Colder, darker, or richer in certain elements than our own. It was as though a piece of another solar system had been delivered to us, glowing in a way that could not be ignored. The visual effect was stunning. Through backyard telescopes, Atlas appeared as a soft emerald flame suspended in the night. Astrophotographers captured long exposures, revealing tails stretching like brushstrokes across the heavens, tinted faintly green against the starfields. Social media filled with images that seemed almost too artistic to be real, but they were. Cultural echoes quickly surfaced. In history, green comets have been omens. Ancient records speak of them as harbingers of change, symbols of growth or catastrophe. Even though modern astronomy explains the chemistry behind the glow, that primal response lingers. To look at Atlas was to feel both awe and unease, to sense that we were witnessing not just another comet, but a cosmic visitor carrying secrets from beyond. And still, mysteries deepened. Why so much green? Why such intensity? Was it simply a matter of chemistry, or did Atlas's long drift through interstellar space alter its surface in ways we haven't imagined? Its glow became a question as much as an answer, a riddle written in light. Night after night, telescopes traced the flame, trying to decode its message. Each photon carried across light years of emptiness before being split into spectra, its secrets laid bare. And yet, even as the instruments spoke, Atlas kept its story incomplete. Familiar, yet foreign. Known, yet unknown. A green flame in the sky, reminding us that even in science, beauty and mystery walk hand in hand. In the same season, another object, Comet Swan R2, brightened unexpectedly. Its trajectory was different, its origin local, and yet it too converged on the inner solar system almost in lockstep with Atlas. For astronomers, this was a surprise. Swan R2 hadn't been predicted, plotted, or anticipated in the usual way. It emerged from the data almost by accident, discovered in images from the Solar and Heliospheric Observatory's SWAN instrument, a camera built not to hunt comets, but to map hydrogen in the solar wind. By chance, its sensors caught the distinct glow of hydrogen streaming off the comet's icy surface, betraying its sudden arrival. This was no faint, distant smudge. Within weeks of discovery, Swan R2 brightened dramatically, enough to be glimpsed with binoculars under dark skies. Its tail grew longer, its coma spread outward, and amateur astronomers across the globe began reporting its presence. For many stargazers, it was the first visible comet in years, a chance to watch, with their own eyes, a piece of cosmic ice racing toward the sun. What made Swan R2 particularly intriguing was its timing. Here was a comet from our own Oort cloud, a distant reservoir of icy bodies that surrounds the solar system. Arriving just as an interstellar visitor, Atlas, was making its closest pass. Their orbits were entirely different, their origins separated by unimaginable distances, and yet, on the stage of the inner solar system, they appeared together. The odds of this convergence were small. For astronomers, it felt like watching two stories, written on opposite sides of the galaxy, suddenly overlap in the same chapter. Swan R2 carried mysteries of its own. Its rapid brightening suggested a nucleus, unusually rich in volatile ices. Perhaps its surface had fractured, exposing fresh material that outgassed furiously in sunlight. Some speculated that its composition might not match typical Oort cloud comets, hinting at a stranger history, maybe a fragment knocked inward long ago, only now making its fiery debut. Observers noted how its behavior differed from Atlas. Where Atlas glowed with a steady green hue, Swan R2's tail seemed restless, reshaped by the solar wind, its ionized gases responding dramatically to fluctuations in the sun's magnetic field. The two comets offered a stark contrast, one slender and stable, its glow a mystery of chemistry, the other flamboyant and volatile, its form changing almost nightly. Together, they transformed the sky. In October 2025, if you found yourself far from city lights, you could stand under the stars and see both Atlas faint but steady, Swan brighter and more sprawling. Few generations have ever been so fortunate. It was as though the cosmos had arranged a duet, two voices singing from entirely different origins, converging in harmony for a brief season. And in that harmony lay the deeper question. Was it all coincidence? Or was there meaning in the timing, a rhythm in the solar system we had yet to understand? Swan R2, born of our own cosmic backyard, had joined the race. But the finish line was still ahead, and the universe had more surprises in store. Two objects from wildly different beginnings, one from the Oort cloud, one from interstellar space, approached the Sun within weeks of each other. The mathematics say this shouldn't happen in a million years, yet it did. Astronomers are comfortable with improbability. The universe is vast, and strange alignments happen by chance from time to time. But the simultaneous approach of comet Swan R2, a child of our own solar system, and 3I Atlas, a wanderer from another star, stretched even the most generous probabilities. Their trajectories were unconnected, their sources unimaginably far apart, and yet they converged on the same stage, the inner solar system in late 2025. Picture the solar system as a vast and mostly empty highway. Planets and comets follow their lanes, some on loops that repeat endlessly, others on one-time passes that exit forever. For two entirely unrelated travelers to arrive side by side is like watching a car from Los Angeles and another from Tokyo, neither aware of the other, merge onto the same stretch of road at the exact same time. Not impossible, but certainly unexpected. The timing raised questions. Was this truly coincidence? Or was there a subtle rhythm in celestial mechanics we didn't yet understand? Could the gravitational tides of giant planets have created overlapping windows, nudging Swan inward as Atlas happened to pass through from beyond? Or was this part of something larger, a clustering of cosmic arrivals hinting at hidden patterns in the galaxy itself? Astronomers debated the possibilities. Some pointed to the ever-growing reach of survey telescopes. We are simply seeing more, they argued, because we are finally able to look more deeply. The Vera Rubin Observatory had only just begun its nightly scans, capable of finding faint visitors that once would have slipped past unnoticed. The coincidence, they suggested, was one of perception rather than reality. Yet for many, that explanation felt incomplete. The skies were busier than usual, not just in data, but in reality. Swan R2 brightened spectacularly, easily visible to amateurs. Atlas carried its emerald glow into the heart of the solar system. Smaller asteroids zipped past Earth in quick succession. The effect was unmistakable, a cosmic traffic jam, with lanes that should have been empty suddenly crowded with visitors. From Earth, it was humbling. We looked up and saw not one rare object but two, and countless others nearby. The night sky felt alive, restless, filled with motion and mystery. For stargazers, it was a gift, a once-in-a-lifetime chance to witness multiple celestial dramas unfolding at once. For scientists, it was a puzzle that gnawed at probability itself. And for dreamers, it was something more. Two objects, born in places unimaginably distant, arriving together as if summoned. A coincidence, perhaps. Or perhaps not. The universe, after all, does not explain itself. Sometimes it simply presents a mystery and asks us to wonder. As Atlas and Swan passed through the inner solar system, their simultaneous presence reminded us of a truth both simple and profound. Space is vast, but sometimes, improbably, paths cross. And when they do, the cosmos feels less like a void, and more like a stage crowded, vibrant, and alive. Then came the swarm. 7 comets, each distinct, all arriving within days of each other in late 2025. Pan-stars, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and Neat, as if 7 old travelers had returned for a reunion at the same moment. To astronomers, it was unlike anything they had seen before. A typical year might bring 1 bright comet, perhaps 2 if fortune favoured us. Most years pass quietly, with faint objects that demand large telescopes to glimpse. But in 2025, the skies grew crowded. 7 comets, each with its own unique discovery story, each following a separate orbit, converged on the same season. The solar system, usually so spacious, suddenly felt busy. Pan-STARRS was the brightest of the group, discovered by the powerful survey telescope in Hawaii. Its orbit promised a dazzling display, visible even to the naked eye, a rare gift for casual stargazers. SWAN, by contrast, was discovered almost by accident, its hydrogen emissions revealed in data from a spacecraft designed to watch the sun. STEREO was more dramatic, a near-sun grazer likely to risk disintegration as it brushed against the star's searing heat. Atlas K1 and Atlas G3 were siblings of a sort, both uncovered by the Asteroid Terrestrial Impact Last Alert System, which tirelessly scans the skies for hazardous intruders. LEMON carried the legacy of Mount Lemon's decades of sky surveying, while NEAT represented the work of an older program, its orbit charted years earlier but only now arriving at its moment in the sun. Each comet was a story unto itself. Yet, arriving together, they seemed like parts of a larger tale. Astronomers could not ignore the clustering. Orbital dynamics are supposed to be random, each object following the pull of gravity with little regard for others. But here, 7 separate actors shared the same stage at once, their timing so precise it appeared orchestrated. For observers on Earth, the swarm offered an unprecedented show. Time-lapse sequences showed the heavens alive with movement, as if the universe were painting with light in broad strokes. Online astronomy forums buzzed with images and debates, amateur and professional astronomers alike marveling at what they were witnessing. And yet, beneath the excitement lay unease. Why 7? Why now? The odds of so many comets becoming visible at once were vanishingly small. If the universe is a vast dice roller, had it just thrown an impossible hand? Or was some unseen influence nudging these objects inward, drawing them together into a cosmic gathering we could not yet explain? Scientists cautioned against overinterpretation. Probability can play tricks, they reminded us. Coincidences happen, but even the most skeptical voices admitted that the sight of 7 comets in a single season was unusual enough to deserve attention. The swarm demanded explanation, if not now, then in the future, when more data and more powerful instruments might reveal the truth. For now, the heavens had offered us a gift. 7 companions, streaking inward together, illuminating our skies, and whispering that the solar system is never as quiet or as predictable as we imagine. On paper, orbital mechanics explain each of them. Yet when plotted together, the clustering jumps out like music notes arranged in harmony. Could gravity alone explain such timing, or was some unseen hand at work? Every comet's orbit is a story written in mathematics. Inclination, eccentricity, perihelion distance, the numbers are cold and exact, leaving little room for mystery. When astronomers charted each of the 7 companions, every trajectory could be explained by the familiar physics of Newton and Kepler. There was no violation of the rules, no invisible planet tugging at them, no obvious anomaly in their paths. Each comet seemed to be acting alone. And yet, when the orbits were overlaid, the effect was striking. Instead of the usual scatter of arrivals stretched across years, here was a tight cluster. Their closest approaches fell within weeks of each other. To the trained eye, it looked like coincidence pushed beyond reason, like chords struck on a piano that by sheer chance happened to form music. Statistically, coincidences do happen. In a universe filled with billions of objects, clusters can occur by chance, the way raindrops sometimes land close together on a window pane. But this felt different. 7 comets, all independently discovered, all arriving in one season, all bright enough to be noticed even without the largest telescopes. For astronomers accustomed to years of sparse skies, the abundance was hard to accept as mere luck. Some proposed natural explanations. Perhaps the solar system was moving through a region of space rich in interstellar debris, stirring both distant Oort cloud comets and interstellar wanderers like Atlas into activity. Others pointed to gravitational resonances, subtle nudges from Jupiter or Saturn, which can occasionally herd objects inward on overlapping timescales. These ideas were plausible, but they felt incomplete, like explanations offered after the fact rather than predictions of what was always bound to happen. Speculation, of course, reached further. Was there some larger rhythm, a galactic tide influencing comets on million-year cycles? Could these arrivals hint at forces we barely understand, dark matter interactions perhaps, or subtle electromagnetic effects spanning light years? No evidence supported these notions, but the clustering was curious enough to spark them. The language of science demanded restraint. Orbital mechanics worked, the data fit. Each comet obeyed gravity, nothing more. But the human mind is not easily satisfied with cold equations. To those watching the skies, the simultaneity felt orchestrated, as if the cosmos had chosen this season for a concert, each comet playing its part in a harmony we could only half hear. For stargazers, this was less about explanation than experience. They looked upward and saw not isolated events but a chorus, multiple streaks of light, each different, yet together forming something greater than the sum of its parts. A cosmic symphony, fleeting and beautiful, that would not play again for generations. Coincidence or chorus? The question lingered. The data leaned toward chance, but the feeling in the heart suggested something more. Perhaps that is the nature of astronomy itself, precise in its mathematics, but poetic in its mysteries. Asteroid FA22, a mountain-sized rock, passed Earth at less than 1 million kilometers. Alone, it might be unremarkable, but clustered within the same time frame, it became part of a larger question: why now? Near-Earth asteroids are not unusual. Our planet shares its orbital neighborhood with countless rocky fragments, leftovers from the formation of the solar system. Many are small, little more than boulders adrift in space. Others are massive enough to cause real concern, prompting dedicated survey programs to scan the skies each night. Most pass unnoticed by the public, slipping by quietly without fanfare. FA22 could have been one of those quiet encounters, remembered only in technical reports. But its timing made it different. In late 2025, when comets and interstellar visitors crowded the sky, FA22 swept past as well, a reminder that our solar system is not just a place of icy wanderers but of rocky neighbours too. At roughly 1 kilometre in size, it was large enough to command attention, and its distance less than 3 times farther than the Moon placed it uncomfortably close in astronomical terms. It was harmless, yes, but uncomfortably noticeable when considered in the larger context of the swarm. Astronomers could not ignore the clustering. Here was an asteroid, unrelated to the comets, following its own path shaped by gravity alone. And yet, like the others, it arrived in the same season. Was this too part of the apparent traffic jam? Was FA22's timing a coincidence, or a hint that more was happening beneath the surface of celestial mechanics than we understood? To answer such questions, researchers dug into its orbit. FA22 had been tracked for several years, its trajectory well predicted. Nothing unusual stood out, no strange perturbations, no signs of an outside influence. Its path was routine, the result of long-term gravitational nudges from Earth and other planets. In purely scientific terms, it belonged exactly where the equations said it would. But science often lives in the tension between what the data shows and what the human mind perceives. To astronomers watching the skies in 2025, FA22 did not appear routine at all. It arrived in the same narrow window as comets from the Oort cloud and even an object from another star system. Alone, it was unremarkable. Together, it became part of a chorus, another note in the harmony of arrivals that stretched the imagination. For those who track near-Earth objects, FA22 carried a second lesson as well. How fragile our awareness island. Even large asteroids can slip through unnoticed until they are already close. Survey systems are better than ever, yet the cosmos still holds surprises. The presence of FA22 among the cluster reminded us of our vulnerability, of how much we depend on vigilance, and how little margin there sometimes is between discovery and encounter. Ultimately, FA22 passed without incident, fading back into the darkness of space. but its timing remained a question mark. Was it simply chance? Or was its presence, alongside the swarm, a subtle reminder that we are part of a larger story, one in which rocks and ice, comets and asteroids, interstellar wanderers and local debris all converge in rhythms we have yet to fully understand? Objects arriving from near the sun's glare pose special problems. They remain invisible until the final approach. If one of Atlas's companions had been on a collision course, would we even have seen it in time? This is one of the great challenges of planetary defense. Most of our telescopes are ground-based, peering outward into the night sky. But near the sun, where daylight overwhelms our view, dangerous objects can slip through unseen. These blind spots are not just gaps in data, they are corridors of invisibility, regions where asteroids and comets can hide until they are suddenly upon us. Astronomers know this vulnerability well. History has already given us warnings. In 2013, a small asteroid entered Earth's atmosphere over Chelyabinsk, Russia, exploding with the force of hundreds of kilotons of TNT. It had approached from near the sun's direction, undetectable by existing surveys. And while Chelyabinsk was small, only about 20 meters across, its shockwave shattered windows across an entire city, injuring thousands. That was just a fragment. What then of something larger? Now, imagine if one of Atlas's companions, one of the 7 comets arriving in 2025, had entered along such a hidden path. Some were bright, easy to see once they moved far enough from the sun's glare, but others were faint until the final weeks, their activity awakening only as sunlight warmed their surfaces. If any had aimed directly toward Earth, our warning time could have been measured in days, not months. This sobering reality is why new survey systems are being built. NASA's NEO-Surveyor, a planned infrared space telescope, is designed specifically to catch these hidden travelers by looking for their heat rather than their reflected light. Placed beyond Earth's orbit, it would be able to scan regions near the sun that are otherwise impossible to monitor from the ground. But in 2025, such tools were not yet fully online. We watched Atlas and its companions through imperfect eyes, keenly aware of what we could not see. The clustering of so many objects only amplified this unease. Each one followed its own orbit, but together they highlighted how little margin there is between safety and surprise. For all our calculations, the cosmos can still slip visitors into our neighborhood unnoticed. And if coincidence could bring us 7 comets at once, could it not also bring us something more dangerous, hidden until the last moment? Yet, there is another perspective, one less anxious, more reflective. The hidden corridor is not only a place of danger, but also a reminder of mystery. The sun itself blinds us from seeing everything at once, holding secrets behind its radiance. Objects emerge suddenly, like actors stepping from behind a curtain, reminding us that the play of the cosmos is ongoing even when our instruments cannot follow. As Atlas and its companions swept through, most arrived safely, only to retreat back into the depths of space. None were on collision courses, but the lesson was clear. The universe is vast, our vision is narrow, and hidden corridors remain. Whether threat or wonder, they are part of the stage on which the cosmic story unfolds unseen until the moment the curtain rises. When the Very Large Telescope turned toward Atlas, it found nickel glowing without iron. In space, metals rarely travel alone. The chemistry suggested something unfamiliar, perhaps even unnatural, about its composition. Astronomers are fluent in a kind of silent language, the language of spectra. Every element, when heated by sunlight, releases light in a pattern of lines as distinctive as fingerprints. From these fingerprints, we can learn what a comet is made of, even across millions of kilometers. Usually, the story is straightforward. Carbon compounds, water vapor, traces of sodium, and often the heavy metals nickel and iron released together as ices vaporize. But Atlas did not tell this familiar story. It spoke in a dialect none had expected. The nickel lines were strong, shining clearly against the spectrum. But iron, its usual partner, its near twin in cosmic abundance, was missing, or at least far weaker than it should have been. To planetary scientists, this was startling. Nickel and iron form together in stars, bound by the nuclear furnaces that forge heavy elements. When they appear in comets, they almost always appear side by side. What could explain such imbalance? One possibility was that Atlas came from a star system where conditions for planet formation differed from our own, favoring nickel-rich compounds. Another was that its long interstellar journey, a voyage perhaps lasting millions of years, had stripped away or altered its chemistry. Exposure to cosmic rays, or collisions with other small bodies in deep space, could have left only the more resilient nickel behind. Yet neither answer felt fully satisfying. There was also a more provocative interpretation. Some speculated that unusual metallic ratios might hint at processes not purely natural fragments of differentiated worlds, perhaps, where molten cores separated elements in ways comets rarely display. If Atlas was a shard of such a body, it would mean we were glimpsing the wreckage of a planet that once circled another star. In that light, its chemistry became a kind of ghost story. The remains of a world long gone, drifting silently between suns until it arrived at ours. Even without such bold speculation, the discovery reshaped how we think about interstellar visitors. Every comet in our own system carries a familiar pattern, shaped by the shared origin of the Sun and its planets. But Atlas reminded us that other systems write different chemical stories, their fingerprints subtly or sometimes dramatically unlike our own. Nickel without iron was more than an anomaly. It was a voice from elsewhere, speaking a line in the universal language of metals that we had never heard before. For those watching from observatories, it was humbling. A faint green smudge in the sky had, with careful listening, whispered secrets about stars, planets, and processes beyond our reach. And though many questions remained unanswered, the message was clear. The universe is more varied than we imagine, and every visitor carries a story written not in words but in light. Data from the James Webb Space Telescope added another layer. Atlas seemed rich in carbon dioxide, poor in water, an unusual balance that hinted at a birthplace colder and stranger than our solar nursery. For most comets we've studied, water ice is the dominant player. When sunlight strikes, the ice sublimates, turning directly into vapor, and creates the brilliant tails that comets are known for. Carbon dioxide is usually present too, but as a supporting note secondary to water, emerging more clearly as comets move farther from the Sun. But Atlas was different. Its emissions told a reversed story. Carbon dioxide dominated, while water seemed curiously scarce. This imbalance intrigues scientists because it speaks directly to where a comet was formed. In our solar system, water condenses easily in the outer regions, while carbon dioxide requires colder, darker environments to remain locked in ice. To find a comet so rich in CO, two suggested Atlas had been born in a place far colder than the Oort cloud. Perhaps even at the icy edge of a distant protoplanetary disk around another star. If so, Atlas was carrying the fingerprints of a nursery unlike anything we had known. Webb's sensitive instruments captured the spectral lines with precision, leaving little doubt. The chemistry of Atlas was truly unusual. Some wondered if the scarcity of water meant the comet's outer layers had been stripped by radiation during its long interstellar voyage, leaving carbon dioxide as the survivor. Others suggested it might reflect the unique conditions of its birthplace, a region where water ice was sparse or where carbon dioxide formed more readily in solid form. Either way, the findings pointed to a history etched in chemistry, waiting to be deciphered. For astronomers, this was more than a curiosity, it was an opportunity. Each interstellar comet is like a time capsule, preserving materials from a solar system that evolved under different conditions. By comparing Atlas with Borisov, and perhaps with future visitors, scientists can begin piecing together a map of planetary nurseries across the galaxy. Already, the contrasts are striking. Borisov carried abundant carbon monoxide, a signature of extreme cold. Atlas leaned heavily toward carbon dioxide. Each told a different story, a different environment, a different origin. The lack of water in Atlas was also symbolic. Water is the molecule we associate with life, with habitability, with our own planet's story. Its absence reminded us that most worlds may not resemble ours. Some may be too cold, too barren, too chemically unbalanced to support anything like the Earth's flourishing biosphere. Atlas whispered of those harsher places, systems where ice is not water but frozen gases, and shadows outnumber warmth. And yet, in its scarcity, Atlas also deepened our appreciation of Earth. We live on a world where water is abundant, flowing freely in oceans, rivers, and clouds. Atlas reminded us how rare that balance might be in the wider universe. Its green flame was not just a scientific puzzle, but a cosmic mirror showing us both the variety of other worlds and the fragility of our own. Alongside its other emissions, Atlas produced cyanogen, a compound with a history of inspiring both scientific curiosity and cultural superstition. Its spectral fingerprint painted Atlas as an object both chemical and symbolic. Cyanogen is a simple molecule made of carbon and nitrogen, but its presence carries weight far beyond its chemistry. In modern astronomy, it is a common feature in comets, identified by its distinctive spectral signature, a bright band in the blue-green portion of the spectrum. For scientists, its appearance is expected, even routine. In 1910, when Halley's Comet returned, astronomers announced that cyanogen gas had been detected in its tail. Newspapers of the time sensationalized the discovery, warning that as Earth passed through the comet's tail, the poisonous gas might flood the atmosphere. Panic spread. Some people bought comet pills to ward off the imagined danger, while others sealed their homes against an invisible threat. Of course, nothing happened. The density of cyanogen in a comet's tail is so low it poses no danger at all. But the episode cemented cyanogen's place in cultural memory as something ominous, almost supernatural. So when Atlas revealed its own cyanogen signature, it was as though the universe was whispering across time, blending science with myth. Astronomers, calm in their knowledge, logged the detection, noting its strength, its ratio to other gases, its behavior under solar radiation. But for storytellers and dreamers, cyanogen carried echoes of older fears of comets as omens, as harbingers of change. What made Atlas's cyanogen particularly intriguing was how it fit into the broader puzzle of its chemistry. Alongside carbon dioxide and diatomic carbon, cyanogen added yet another unusual ratio to the mix. It suggested Atlas's birthplace was rich in volatile compounds, perhaps colder and darker than our solar nursery. In that sense, cyanogen was not just a curiosity. It was a clue, pointing to the alien conditions that shaped this interstellar wanderer. And yet, beyond its scientific meaning, there was symbolism. Cyanogen is invisible to the naked eye, its presence known only through instruments that split light into its hidden colors. It is a whisper in the spectrum, a quiet voice telling us of the comet's history. For those attuned to cosmic metaphors, this whisper carried resonance. It reminded us how much lies beyond ordinary sight, how the universe is filled with secrets that reveal themselves only to those who listen carefully. For amateur astronomers capturing Atlas with cameras, the greenish hue in their images was a blend of cyanogen and carbon emissions, transformed into something visible and hauntingly beautiful. For the public, the photos circulated online were less about molecules and more about wonder. A faint green flame, a whisper in the dark, glowing from a visitor that had crossed untold distances to arrive here. In the end, cyanogen in Atlas was both mundane and profound. A molecule, yes, a spectral line on a graph, precise and unambiguous, but also a story of superstition and science, of whispers across centuries, of humanity's enduring tendency to see more than data in the night sky. For Atlas was not only chemistry, it was myth reborn in emerald light. Each of the 7 comets carried its own story. Pan-STARRS with its brightness, Stereo diving toward the sun, Lemon discovered from Mount Lemon's steady gaze. Together, they formed a tapestry no one expected. Pan-STARRS was the showpiece. Its orbit promised a comet bright enough to be glimpsed without a telescope, a rare treat for the casual skywatcher. Discovered by the Panoramic Survey Telescope and Rapid Response System in Hawaii, it quickly became the brightest of the group, a beacon visible even in suburban skies. For weeks, it painted delicate arcs across the heavens, its dust tail shimmering in the wake of its journey. Stereo was the daredevil. Unlike the others, it plunged dangerously close to the sun, earning the title of a near-sun grazer. Many such comets do not survive. They dissolve into streams of gas and dust under the star's searing heat. Observers waited anxiously, wondering whether Stereo would endure or vanish. In its final approach, its brightness spiked dramatically, then faded, a cosmic flare marking the end of its fiery dive. Lemon was the quiet participant, discovered by astronomers at the Mount Lemmon Survey, a long-standing program dedicated to spotting near-Earth objects. Though less dramatic than Pan-STARRS or Stereo, it contributed a steady, reliable presence to the swarm. Its faint but persistent glow reminded astronomers that not every member of the gathering needed spectacle to be significant. Then there were the two Atlas discoveries, K1 and G3. These siblings of a sort bore the mark of the Asteroid Terrestrial Impact Last Alert System, the very same network that first revealed 3I Atlas itself. Their detection underscored the power of systematic skywatching, the quiet vigilance of automated instruments that scan the heavens night after night. They were not the brightest, but their timing added to the strange convergence, as though the system that gave us our interstellar visitor had also revealed its local cousins. NEAT was a legacy comet, discovered years earlier by the Near-Earth Asteroid Tracking Program. Its presence was a reminder that not every arrival was new. Some had been foretold by mathematics, their paths mapped with confidence. Yet its role in the swarm gave it fresh significance, transforming it from routine prediction into part of an extraordinary moment. And Swan, of course, carried its own drama. Spotted almost by accident by the solar wind, Anisotropi's camera aboard Soho, it brightened with surprising vigour, earning its place as one of the most photogenic of the group. Swan's broad, sprawling tail contrasted sharply with the disciplined green glow of Atlas, the two together forming a spectacle few had ever dreamed of seeing. Taken separately, these comets were simply a collection of icy travellers, each discovered by different surveys, each following its own orbit, but together they became something more. A roll call of the unexpected, a gathering that seemed less like coincidence and more like choreography. In their diversity, they told us that the cosmos is full of stories, and in their unity, they reminded us that sometimes those stories converge into a single, unforgettable chapter. Most years, we're lucky to see even one comet without a telescope. 2025 brought 7. Even with new surveys scanning the skies, the clustering defied statistical expectation. This wasn't just better observation, it was unusual reality. Astronomy often deals with long waits. A bright comet visible to the naked eye is a once-in-a-decade event, sometimes once in a lifetime. Whole generations have lived under quiet skies, while ancient records speak of eras when comets seem to come in flocks. 2025 was one of those rare years, a year when the heavens refused silence, filling the sky with icy visitors that appeared in uncanny synchrony. At first, many pointed to technology. The Vera Rubin Observatory had just begun operations, sweeping the night sky with an unprecedented digital eye. Its wide field of view allowed it to capture faint objects in real time, discovering more than older observatories could ever hope to. Surely, some said, we were seeing more simply because we had become better at looking. And yet, that explanation felt incomplete. Surveys alone could not explain why so many comets happened to swing inward at once. They were not faint stragglers pulled into visibility by advanced cameras. These were bright, dramatic comets, many visible to the naked eye, some dazzling through binoculars or small telescopes. Even the most skeptical astronomers admitted. Discovery methods aside, the clustering itself was real. The timing raised deeper questions. Why now? Was there a natural cycle we had overlooked, a hidden resonance among distant icy bodies that occasionally sends them inward in waves? Was the solar system itself passing through a region of the galaxy that stirs comets from their slumber? Or had gravitational nudges from Jupiter or Saturn aligned in such a way that the outer reservoirs of ice were disturbed? No single explanation fit cleanly. Probability told us this should not happen. Yet here it was, unfolding in plain sight. Like dice rolled at a casino table, the universe had given us a string of unlikely outcomes, one after the other. For skywatchers, the why was less important than the experience. People around the world lifted their eyes to see streaks and glows that had not graced the skies in years. Social media filled with photographs, green flames, golden tails, faint arcs against starry backdrops. Children who had never seen a comet before saw not one, but many. Entire communities rediscovered the thrill of watching the heavens directly, no telescope required. Still, the question lingered. Why this year? Why 7? In the cool hours of night, astronomers found themselves not only taking data, but quietly marveling, as though the cosmos itself had chosen 2025 for a spectacle. Coincidence, perhaps? Or perhaps the alignment of forces we do not yet fully understand. Whatever the cause, 2025 became a reminder that the universe is not static. It breathes in rhythms we do not always perceive, and sometimes those rhythms surge into view. For one remarkable year, the sky opened its hand and revealed more than we had expected, a gift of 7 comets delivered all at once. Our sun was restless in 2025, nearing the peak of its 11-year cycle. Solar storms amplified comet tails, making the sky more dramatic. Yet activity alone couldn't explain the sudden abundance of bright visitors. The sun is not a steady, unchanging beacon. It breathes in cycles, waxing and waning in magnetic activity every 11 years. At its quietest, sunspots nearly vanish, solar flares grow rare, and the solar wind eases. But at its most active, the surface seethes with dark spots, eruptions arc high into space, and storms sweep outward across the solar system. The sun had entered its maximum, its restless energy shaping the space around it. For comets, this matters. Their delicate tails, one of dust, the other of ionized gas, are sculpted by the solar wind and magnetic fields. During solar maximum, these winds strengthen and shift unpredictably, twisting comet tails into ribbons, forks, or even sudden disconnections when a magnetic storm snaps them apart. Observers in 2025 saw these effects clearly. Comet tails that should have streamed smoothly instead writhed and bent as though alive, painted by the sun's invisible hand. The heightened solar activity also made comets brighter. Energetic radiation struck their surfaces, heating them more rapidly, liberating gases and dust in greater quantities. Even modest comets appeared more spectacular under these conditions. Their comae swelling, their trails luminous against the night. For the casual skywatcher, this made 2025 a golden year. Not only were there many comets, but each one looked more dramatic than it might have under quieter solar skies. Still, astronomers cautioned against seeing the sun as the full explanation. Solar maximum can amplify the show, yes, but it cannot summon visitors out of nowhere. The sheer number of comets arriving remained beyond what solar activity alone could explain. The sun provided the stage lighting, but the actors had already chosen to appear. What the sun did offer, however, was variety. Stereo, the near-sun grazer, endured some of the most extreme effects, its tail contorted as it plunged through the fiercest regions of solar magnetism. Swan displayed sudden outbursts as jets of gas were triggered by solar storms. Even Atlas itself, though interstellar, responded to the solar cycle, its green glow flaring and shifting with the sun's moods. For scientists, solar maximum became both a complication and a gift. It introduced noise into the data, making it harder to separate intrinsic cometary behavior from solar interference. But it also revealed how sensitive comets are to their environment, turning each into a natural probe of solar weather. By watching their responses, astronomers could infer details about the solar wind invisible to instruments alone. And for those who simply gazed upward, the sun's influence was artistic. Night after night, comets stretched luminous trails across the sky, their forms unpredictable, shifting, alive. The sun, though unseen at night, had signed its name across the heavens. In the end, solar maximum was part of the story and amplifier, not a cause. The visitors came on their own paths, drawn inward by forces still debated. But in 2025, the sun ensured that when they arrived, they glowed more brightly, their voices louder in the cosmic chorus. Could a massive unseen planet be shepherding these objects inward? Gravity leaves fingerprints in orbital paths. So far, no obvious culprit appears, yet whispers of Planet 9 echo in the debate. Astronomers are detectives of motion. They watch how comets bend, how asteroids drift, how planets tug at one another. From these subtle shifts, they can infer hidden presences. Neptune itself was discovered this way, its existence deduced from irregularities in Uranus's orbit long before telescopes captured it directly. In much the same way, some have wondered whether the clustering of comets and asteroids in 2025 was more than coincidence. Perhaps something massive lurks on the outskirts of the solar system, its gravity shaping events from afar. For years, astronomers have speculated about Planet 9, a hypothetical world, perhaps 5 to 10 times the mass of Earth, orbiting hundreds of times farther from the Sun. Its existence was suggested by the odd clustering of certain trans-Neptunian objects, whose orbits all seemed tilted in the same strange direction. A hidden giant, it was argued, might be holding them in alignment. If such a planet exists, it could also send occasional waves of comets inward, disturbing the frozen reservoirs at the edge of the solar system and feeding them into the inner regions. The idea is tantalizing. One massive world, unseen in the darkness, could explain why so many icy travelers arrive together. Its influence would be gentle but persistent, nudging orbits across millions of years until a cluster of objects reached the Sun at nearly the same time. To astronomers, this would be gravity's signature, not direct evidence of the planet itself, but the patterns it sculpts into everything around it. And yet, despite years of searching, Planet 9 remains elusive. Some argue that if it exists, it may be far dimmer and more distant than expected, hidden against the dense star fields of the Milky Way. Others have suggested the clustering of orbits may be an illusion, a result of observational bias rather than genuine alignment. The debate continues, unresolved. Still, the swarm of 2025 revived the whispers. Could the comet's timing be another clue, another faint tug of the invisible hand? Or was it all coincidence, chance piled upon chance? The data offered no clear answer, only the suggestion that something more might be happening beyond our view. For dreamers, the idea is irresistible. A hidden planet, waiting to be discovered, its slow gravity shaping the solar system's destiny from the shadows. For scientists, it is a challenge to distinguish between patterns born of nature and those conjured by our own desire for explanation. As Atlas and its companions swept past, their orbits were logged, their paths mapped with precision. Yet the possibility remained, a quiet note in the background of the debate. Gravity is patient. It does not rush. If something massive waits beyond Neptune, its fingerprints will appear again and again, until the evidence is undeniable. For now, Planet 9 remains a whisper, a hypothesis woven into the mystery of why so many visitors arrived together in 2025. A reminder that even in the age of advanced telescopes, the solar system may still hold secrets vast enough to reshape our understanding of home. Comets are charged objects, their gases ionized by sunlight. Could solar magnetic fields twisting and tugging have coaxed multiple comets inward at once? It seems possible, but unlikely on such grand scales. When a comet nears the Sun, its ices sublimate, releasing gas and dust into a shimmering coma. Some of those gases, like carbon monoxide or water vapor, remain neutral, but others are ionized, stripped of electrons by the sun's relentless ultraviolet light. These charged particles do not move freely. They are caught up in the solar wind, twisted and guided by magnetic fields that ripple outward from our star in vast, invisible currents. This is why comets display not one tail, but two. The dust tail curves gently, following the comet's orbit. The ion tail, however, stretches straight back, blown outward by solar wind, often glowing blue from ionized carbon monoxide. These ion tails are direct evidence of electromagnetic forces at work, shaping fragile celestial bodies across millions of kilometers. Some astronomers have wondered whether these same forces might not only sculpt comet tails, but also nudge entire comets themselves. Could variations in the solar wind, perhaps intensified by the solar maximum of 2025, have helped funnel multiple comets inward at the same time? If so, electromagnetic currents might play a larger role in comet dynamics than we usually assume. It is an intriguing thought, but most scientists remain cautious. The mass of a comet is vast compared to the delicate ions in its tail. Gravity is the dominant force guiding its orbit, while electromagnetic effects are subtle, acting mostly on the gases already freed from the nucleus. To imagine that solar fields could herd whole comets inward stretches physics beyond what we've observed. In a universe of hidden interactions, might there be electromagnetic influences we have not yet fully measured? The very act of asking reflects the restless curiosity of science. Each anomaly, each cluster of comets, each coincidence invites us to revisit old assumptions. Could the sun's tangled magnetic field extend its reach farther than we thought? Could interplanetary space hold structures of plasma and charge that subtly alter trajectories over long timescales? We do not yet know. Still, electromagnetic shadows are real in a different sense. They appear in the way comet tails flicker and twist under solar storms, sometimes disconnecting entirely as magnetic fields snap. In 2025, several of the swarm displayed these effects, their tails bending suddenly, their shapes transformed overnight. The sun's influence was visible. A reminder that even in the emptiness of space, invisible forces are at play. For skywatchers, these changes only deepened the spectacle. To see a comet's tail shift shape from one evening to the next was to witness the hidden power of the sun in action. For scientists, it was data, an opportunity to study space weather by watching how fragile travelers responded. Ultimately, electromagnetic forces could not explain the sudden abundance of comets in 2025, but they did shape how we saw them, both literally and figuratively. The cosmos reminded us that gravity is not the only sculptor of orbits, and that in the shadows of magnetic fields, comets dance to rhythms we are only beginning to hear. When Atlas makes its near pass by Mars, as early as 3rd October 2025, our probes orbiting the red planet will have the rare chance to witness it up close. MAVEN, with its instruments tuned for gases, could analyze the strange chemistry of its glowing coma. Mars Reconnaissance Orbiter, usually focused on mapping dunes and craters, might turn its gaze outward for a glimpse of the interstellar visitor. Even Perseverance, sitting in Jezero Crater, could look skyward and capture the faint streak of green in the night. If these observations take place, it would be the first time humanity has studied an interstellar object, not only from Earth, but from another planet as well. Two vantage points, millions of kilometers apart, could allow scientists to triangulate its structure in unprecedented detail, turning a flat sketch into a three-dimensional portrait. We cannot yet know what data will be gathered, or how clear the images might be. But if the opportunity is seized, Mars could become more than a world we explore. It could become a partner in astronomy, extending our senses outward and giving us new eyes on a cosmic traveler. As Atlas drifts closer to the Sun, there will come a point when Earth-based telescopes grow blind. In the glare of daylight, even the most powerful instruments will lose sight of its green glow. We will wait, holding our breath, for it to re-emerge weeks later. And in that silence, speculation will inevitably grow. This is the rhythm of comet watching. For a time, an object brightens night by night, each observation adding new detail. But then, inevitably, it slides into the brilliance of the sun, beyond reach. It is during that invisibility that the greatest questions hang. Will Atlas survive its solar passage? Or will it fragment and fade before we see it again? Some scientists will argue for survival, noting its size and resilience. Others will point to its unusual chemistry, fragile balances of carbon dioxide and cyanogen, and suggest that it may be more delicate than it appears. The truth will remain hidden, tucked behind the sun, until it chooses to reveal itself again. For those watching from Earth, the waiting will feel long. Weeks without data, nights without sight. Yet the anticipation itself is part of the story. A reminder that the universe keeps its own time, and that sometimes discovery comes only through patience. Some scientists wondered aloud, was Atlas a lone shard from a distant planetary system, or part of something larger? Could the swarm be more than coincidence, a caravan crossing interstellar space? Comets are usually solitary travelers. They are fragments of ice and dust cast outward long ago, wandering the dark until a chance encounter with gravity sends them inward. Each follows its own orbit, indifferent to the paths of others. But the appearance of Atlas among a chorus of companions stirred a different thought. What if this was not random? What if interstellar objects sometimes travel together? It is not impossible. Stars are born in clusters, their planets forming amid swirls of gas and dust. When those systems interact, gravitational chaos can eject comets and planetesimals in groups rather than singles. Imagine a young solar system disrupted by the passage of a neighboring star, debris flung outward, not as isolated shards but as caravans, drifting together for millions of years before scattering. If Atlas had once belonged to such a caravan, it may have arrived in our skies as part of something much larger than itself. Astronomers also considered the possibility of fragments. What if Atlas was once part of a larger body, a planetesimal, or a giant comet torn apart by collisions or tidal forces in its home system? Pieces could have been scattered into interstellar space, sharing similar trajectories. If so, Atlas might not be an individual story but a single page from a larger book we cannot yet read. The swarm of 2025 made this speculation feel less like fantasy. 7 comets, 1 interstellar, all appearing in the same season. Coincidence seemed strained. Could the others have been fellow travelers, their paths diverging across light years, only to reconverge by chance within our solar system? The mathematics is daunting, but the imagination lingers. Science, of course, demands caution. The known comets of 2025 had well understood origins within our own system. Their orbits, mapped with precision, showed no evidence of an interstellar past. Yet the timing pressed the question, why now? If not a shared origin, then perhaps a shared influence, a rhythm or a wave, carrying multiple objects inward together. For those who dream beyond data, the idea of a caravan is haunting. A fleet of icy wanderers, travelling between stars, carrying the chemistry of alien nurseries. Each one a message in a bottle, released long ago, now washing against the shores of our solar system. Perhaps we only caught a glimpse of one emissary, Atlas, while its unseen companions passed silently in the dark. And in a way, the thought changes everything. To see Atlas as part of something larger is to imagine a universe not of isolated fragments, but of current streams of material moving across interstellar space, carrying echoes of distant systems. A cosmic migration, subtle but real, linking stars not only with light but with matter itself. Whether true or not, the possibility lingers. Atlas may be alone, or it may be part of a hidden caravan. Either way, its passage through our skies leaves us with the same quiet realization. We are connected, however faintly, to worlds beyond our own. Statistical models struggled. The odds of so many arrivals within weeks were vanishingly small. And yet, the data was undeniable. The universe had rolled a set of cosmic dice, and we were left to interpret the throw. Astronomers are no strangers to chance. They calculate probabilities every day, the likelihood of an asteroid crossing Earth's orbit, the odds of a planet aligning with its star in such a way that we can see a transit, the frequency of comets bright enough to pierce the sky. Most of the time, the numbers behave. They sketch a universe of rare events, but not impossible ones. In 2025, however, those numbers faltered. 7 comets, 1 interstellar object, and a handful of near-Earth asteroids all arrived in the same season. Each alone was within expectation. Each had a plausible orbit, a reasonable explanation, a calculable path, but together, the clustering stretched probability to its breaking point. It was as if a deck of cards had been shuffled and, by sheer chance, 7 aces had surfaced in a row. When faced with such improbabilities, 2 instincts arise. The first is to accept coincidence. The idea that the universe, vast and indifferent, occasionally aligns events in ways that appear meaningful but are truly random. The second is to suspect hidden causes, forces, or patterns we have not yet uncovered. In the case of 2025, both instincts competed. Was it a trick of numbers or a sign of something deeper? Statisticians caution that our minds are wired to see patterns. A cluster of arrivals may feel extraordinary simply because it stands out against the long stretches of quiet. We remember the rare event, not the centuries of silence that came before. To call it improbable may be more about perception than reality. Yet even with these caveats, the swarm of comets remained striking. Calculations suggested such a cluster might occur only once in tens of thousands of years. And yet, here it was, unfolding before us. Some astronomers speculated about galactic influences. The solar system drifts through the Milky Way, crossing regions of varying density, where gravitational tides or interstellar clouds might disturb comets in the distant Oort cloud. Perhaps 2025 marked the crest of such a wave, sending icy bodies tumbling inward together. If so, the swarm was not random at all, but the visible edge of a cycle spanning millions of years. Others considered observational bias. Maybe swarms had happened before, but we lacked the technology to notice. Before the rise of all-sky surveys, faint comets could slip by unseen, their arrivals lost to history. Now, with advanced telescopes scanning every night, we may simply be seeing what has always been there. Yet this explanation, too, felt incomplete. The brightness of the comets, their sheer visibility, demanded more than technology alone. And so the problem of probability remained. Were we witnessing a statistical fluke, a once-in-an-epoch coincidence, or had the universe revealed a pattern we had yet to recognize? Perhaps both answers hold truth. Chance and cause may dance together, indistinguishable to our limited perspective. What matters, in the end, is that the dice were rolled, and for a brief moment, the universe placed its aces on the table, inviting us to wonder why. Throughout history, comets arriving together were seen as omens, warnings of war, change, or cosmic upheaval. In 2025, those echoes returned, not in prophecy, but in the quiet unease of coincidence too sharp to ignore. For ancient peoples, the sudden appearance of comets broke the rhythm of the heavens. The stars were fixed, reliable, eternal. The planets wandered slowly, but predictably. But comets, they arrived without warning, glowing with tails that seemed to pierce the sky. To societies built on the belief that the heavens were orderly, such disruptions could only mean something extraordinary was at hand. In China, detailed records describe comets as broom stars, sweeping across the sky to clear away dynasties or herald new rulers. In medieval Europe, comets were feared as portents of plague, famine, or war. The Bayeux Tapestry, which chronicles the Norman conquest of England in 1066, famously depicts Halley's comet hanging in the sky above the battlefield, a sign to contemporaries that destiny itself had shifted. Even as late as the 19th century, comets carried cultural weight. When Halley's comet returned in 1910, newspapers played on fears of cyanogen in its tail, sparking widespread panic. The arrival of not one comet, but many, was even more unsettling. Multiple comets in the sky at once seemed to suggest urgency, as though the cosmos was shouting, not whispering. Records from ancient cultures describe years when comets clustered together, often followed by turmoil on Earth. Whether coincidence or correlation, the memory of those years lived on in stories, binding comets with change in the human imagination. And so, in 2025, when 7 comets and 1 interstellar visitor arrived together, it was natural for those echoes to return. Not in the form of prophecy, perhaps, but in the quiet feeling that the year was unusual, charged with a kind of cosmic intensity. Astronomers reassured the public that no danger loomed, that the clustering was scientifically remarkable but not threatening. Yet even scientists admitted to a sense of awe and a faint unease. The cultural echo resonated beyond fear. For some, the crowded skies inspired reflection on humanity's place in the cosmos. Comets, once dreaded, are now studied with instruments, dissected by spectroscopy, even visited by spacecraft. And yet, their symbolic power endures. A sky filled with glowing tails stirs emotions older than science, reminding us that we are storytellers as much as observers. Artists, photographers, and writers seized on the moment. Paintings and images of the comet swarm spread widely online, shared not only as scientific curiosities but as symbols of mystery and beauty. Modern society may not read them as omens of doom, but the instinct to find meaning in them remains. We still look upward and ask what it means when the heavens change. The swarm of 2025 bridged 2 worlds, the scientific and the symbolic. On one side, it was data, orbits, spectra, probabilities. On the other, it was a living myth. A reminder that comets have always been more than ice and dust. They are mirrors, reflecting both the science of the universe and the stories we tell about ourselves. Even as instruments gathered terabytes of data, the most haunting questions were not about molecules or orbits. They were about meaning. Why now? Why together? And could we even recognize the answer if it appeared? Science thrives on precision. Telescopes measured the composition of Atlas's coma, satellites charted its trajectory, and computer models calculated probabilities of impact or survival. Every figure was logged, every photon counted, every equation refined. Yet, beneath the mathematics, a deeper current of inquiry stirred the kind that numbers alone could not quiet. Why did Atlas arrive in this particular year? Flanked by a chorus of comets, why did its chemistry differ so starkly from anything we had seen before? Was this truly coincidence, or was there a hidden pattern we lacked the tools to perceive? These were not questions that could be answered with data alone. They were questions of perspective, of whether our framework for understanding the cosmos is broad enough to encompass the improbable. For centuries, humanity has wrestled with such questions. Each anomaly, the wandering planets, the retrograde motion of Mars, the faint smudge of galaxies once mistaken for clouds, has forced us to widen our lens. Atlas may yet be another such lesson, pushing us to think beyond what is convenient or familiar. Perhaps the swarm of 2025 was nothing more than chance. Or perhaps it was a clue, pointing to cycles of galactic tides, hidden planets, or patterns in interstellar migration that we are only beginning to imagine. And then comes the harder question. Would we even know the answer if it appeared? Suppose Atlas truly was part of a caravan from another system, fragments of worlds scattered across the galaxy. Suppose the timing of the swarm was shaped by forces on scales too vast for us to model. Would we recognize the message in such events? Or would it slip by, dismissed as noise in the data, another curiosity filed away in archives? This is the silent challenge of astronomy. The universe speaks in languages we do not fully understand. Light, gravity, chemistry, these are its words, and we are only beginning to learn their grammar. Atlas was one such word, bright and fleeting, its meaning uncertain. The comets that accompanied it were others, forming perhaps a sentence, or perhaps only a random scattering of syllables. Whether it was poetry or coincidence, we do not yet know. For those who watched, the silence between answers was as haunting as the questions themselves. To lie beneath the night sky in 2025 was to feel both wonder and mystery. The heavens had spoken, but the message remained unfinished. And maybe that is the point. The universe does not reveal itself all at once. It asks us to dwell in questions, to be patient with uncertainty, to find meaning not only in answers but in the act of asking. Atlas and its companions may have passed on, fading back into the dark, but the questions they left remained silent, unresolved, and deeply human. Eventually, Atlas and its companions will slip away, fading into the sun's light or retreating to the far reaches of the solar system. What will remain are fragments of data, unanswered questions, and perhaps the quiet sense that our skies have hosted a gathering we may not see again for centuries. Such is the way of comets. They arrive suddenly, burn briefly against the canvas of the heavens, and then vanish back into the abyss. Some will return in decades or centuries, their orbits predictable, woven into the rhythms of time. Others, like Atlas, may be interstellar, one-time travelers. For them there will be no encore. Their paths will carry them outward, away from the sun, never to circle back. For astronomers, the parting of Atlas will likely be bittersweet. The data gathered will be immense: spectra, orbital calculations, images from Earth, perhaps even from Mars. Yet no matter how detailed, the evidence may still feel incomplete. The chemistry might hint at alien nurseries without revealing them. The clustering may tease hidden patterns without proving them. Atlas could carry stories of other worlds, but in whispers too faint to fully decode. And so, Atlas may leave behind a paradox: abundant evidence, yet lingering mystery. Perhaps that is the truest gift of such encounters. They remind us that science is not a finished book, but an unfolding story, one in which every answer folds into a larger question. When it does fade, the night will return to its stillness. Stars will resume their steady patterns. Planets will continue on their ancient paths. The drama will be over. But the memory of it, and the questions it leaves behind, may stay with us long after the comet itself has passed into the dark. And so, the story of 3i Atlas drifts into silence, as all cosmic tales eventually do. For a brief span of months, our skies became a stage where interstellar visitors, ancient comets, and restless asteroids converged. They shimmered, flared, and vanished, leaving us with questions that echo long after the light has faded. We learned of green flames and hidden chemistries, of carbon dioxide where we expected water, of nickel without iron. We saw 7 companions arrive in harmony, each bearing its own story. We wondered about solar storms, distant planets, and hidden gravitational hands that may have shaped the chorus. And through it all, we asked the oldest questions. Why now? Why here? Why together? Perhaps the answers will come in time, or perhaps they will remain mysteries, folded into the darkness of space, waiting for future generations to unravel. What matters is not only the answers, but the wonder that comes with asking. To gaze upward is to join a lineage stretching back thousands of years of humans who looked at comets and saw omens, who looked at stars and saw stories, who looked at the sky and felt the pull of something greater than themselves. Tonight, as you close your eyes, you are part of that lineage. You share in the wonder of living beneath a sky that is alive, shifting, and filled with surprises. The universe is vast, and we are small, but in that smallness is something extraordinary. The ability to notice, to marvel, to be grateful for the fleeting beauty of visitors like Atlas. May your rest be as calm as the night sky after the comets have passed. May your dreams carry you outward, into the dark, where mysteries await, and where wonder never ends.